Hey everyone, welcome back to Wrath of Math. In today's video, we'll be going over how to subtract matrices. This is a viewer-requested video. I always appreciate those viewer requests, so be sure to leave your requests down in the comments. Now, if you already know how to add matrices, subtracting should be very easy. If you don't know how to add matrices, I'd recommend checking out my lesson on how to add matrices, and then coming back to this lesson. But either way, you should be able to understand this lesson just fine. So here's an example where we are subtracting two matrices. And the first thing I should point out is that, like with addition of matrices, in order to subtract two matrices, they need to have the exact same number of rows and columns. So as you can see in this case, both matrices have 2 rows and 2 columns. So these are both 2 by 2 matrices, so we can subtract them. If, say, this matrix over here had 1 extra column with maybe a 0 and a 5 in it, we would no longer be able to subtract these matrices. This would be undefined, because now this matrix has 3 columns, whereas this one has 2. So they don't have the exact same dimensions, so we would not be able to subtract them. But these 2 matrices we can subtract. So what do you think this is going to be equal to when we subtract this matrix from this one? You probably think that the most natural way to subtract these matrices would be to subtract each entry in this matrix from the corresponding entry in this matrix, and you would be correct. Just like adding matrices, this works pretty much the exact same way. We just have to subtract the corresponding entries in the matrices. So when we subtract these 2 matrices, the entry in the first row and first column is going to be the entry in the first row, first column of this matrix, which is 1, minus the entry in the first row, first column of this matrix, which is 3. So that's 1 minus 3. Then for the first row, second column, we just take the entry in the first row, second column of this matrix, which we see is 2, put 2 there, and then subtract the entry in the first row, second column of this matrix, so 2 minus 4. And then we continue in that way. So all we're doing when we subtract this matrix from this matrix is we are subtracting the entries that are in the same position, and we put that difference in the same position in our new matrix. So 3 and 5 are in the same position, so we do 3 minus 5, and that goes in the same position in this matrix. That position being the second row and the first column. So then what are we going to have in this last entry here? Well, it's going to be 4 minus 6. So write that here, 4 minus 6, and close the matrix. Now let's just move it on over to the left while we finish up this operation. We have 1 minus 3, that's negative 2. 2 minus 4, that is also negative 2. We have 3 minus 5. That's negative 2, and 4 minus 6, that's negative 2. I did not plan this. That is a funny coincidence. Now, just like with normal subtraction, the subtraction of matrices is not commutative. So here's another example of some subtraction with matrices. We have this matrix minus this matrix. Let's write out what that's going to be. We have 1 minus 4 in the first row, first column. So 1 minus 4, well, that's just negative 3. Then second row, first column, we'll have 2 minus negative 3. 2 minus negative 3, that's the same as 2 plus 3, and that is 5. Then what are we going to get if we change the order that we do the subtraction in? You probably already have a decent idea of what will happen from your experience with normal subtraction of real numbers, but let's write it out just to see what's going to happen here. We'll have 4 minus 1, that's going to be positive 3, the opposite of negative 3, and then we'll have negative 3 minus 2, that of course will be negative 5, which is the opposite of 5. But you might remember something cool that we can do with real numbers. While 2 minus 3 is not equal to 3 minus 2, we can treat subtraction as the addition of a negative. So we could write 2 minus 3 as 2 plus -3. And addition is commutative, so now we could commute these two numbers. So by that, I mean that 2 plus -3 is equal to -3 plus 2. We can do the same exact thing with matrices, so let's scroll back up to this example. Let me just move this stuff down to make a little bit more room. We could rewrite this as the addition of a matrix with another matrix that's being multiplied by a scalar. So instead of this matrix minus this matrix, we could write this matrix right here plus -1 multiplied by this matrix. Same sort of thing that we were doing with the real numbers. If you're not familiar with the scalar multiplication of matrices, I have a video lesson on it, so you could go check that out. But it's pretty simple. When we multiply a matrix by a scalar, in this case a scalar is just a real number, all we have to do is multiply every entry in the matrix by that real number. So now that we've turned this subtraction into the addition of a negative, we can commute these two matrices. So let me move them over to the side a little bit. This is equal to -1, a scalar of -1 multiplied by the matrix containing 4 and -3, just like that, plus this matrix here having entries 1 and 2. And then let's continue a little bit with this string of inequalities. This is equal to carrying out that scalar multiplication. Remember, we just have to multiply each entry in the matrix by the scalar. So 4 times -1, that's -4. -3 times -1, that's +3. And then we're just adding this matrix with 1 and 2. And then we just do the matrix addition, where we add the entries that are in the same locations. So -4 plus 1, that's -3, and then 3 plus 2 will give us +5. And you can see that we get the same answer as we did up here. Because again, all we did was we rewrote this subtraction as the addition of a negative. And then since we're dealing with addition, we were able to commute the matrices without changing the result. So the point is that the subtraction of matrices is not commutative. The order does matter. But just like with real numbers, you can treat subtraction as the addition of a negative. And that can be handy because that does allow you to move things around. And I think that is just about where we will leave it for today. So just one more time, remember that to subtract matrices, they need to have the exact same dimensions. They need to have the same number of rows and the same number of columns. Then all you have to do to carry out that subtraction is subtract entries that are in corresponding positions. You'll end up with a matrix that has the exact same dimensions as the matrices you began with. And that's really all there is to it. So I hope this video helped you understand how to subtract matrices. Let me know in the comments if you have any questions, need anything clarified, or have any other video requests. Thank you very much for watching. I'll see you next time, and be sure to subscribe for the swankiest math lessons on the internet. And a big thanks to Valo, who, upon my request, kindly gave me permission to use his music in my math lessons. Link to his music in the description.